Yes, you guys are audible. Good morning. Hope you all can hear me.
Yeah, hi Shaik, good morning. Yeah, we can hear you.
Yeah, yeah.
Great. Thanks for confirming. Okay, let us start the session. Just recap what we have done yesterday is that we have seen what is data engineering. If some people did not understand yesterday, that's perfectly fine. So we can also have a few things discussed from yesterday as well. So this is what is data engineering and Google Cloud Platform we have discussed yesterday. And data engineering is getting the data from multiple data sources. And for the I mean the main importance of the data engineering is to send the data to the downstream by cleaning the data, by preparing the data, so that they can able to create the reports in BI, machine learning, and data scientists and business groups. And if we wanted to do such kind of a things, or if we wanted to send the cleaned data, we need to first extract the data from the multiple data sources and store it the data in a data lake. And after that, do the data processing so that whatever the data we are getting the data from the sources may not be in a usable format, so that we try to convert it into usable format, and then we store the data into the data warehouse. And after that, we will be creating analysis reports based on the user requirement. And to make sure the data is accurate throughout the platform, we are also having the data governance and data monitoring systems as well. 1 minute, guys. Okay, so we get the data from the source, we store the data, we process the data, we again do the analysis on top of our data, and we send the data to the downstream. This is what is data engineering. And during our data engineering, we not only collecting, organizing, and preparing a large amount of the data for the analysis, we also have to design and build the systems and the infrastructure that which is required for all of these processes. Okay, so this is what is the data role of a data engineer: data acquisition, data storage, data processing, data quality, system integration, performance optimization, and monitoring and maintenance. A Google Cloud Platform, we have seen what is that. So Google Cloud Platform is very simple, guys. It's also one of the leading cloud provider to provide you the cloud computing services for your organizations to build, deploy, and scale your applications in the cloud platform itself. So what are the services that the GCP is providing, if someone asks me? So there are more than 200 plus services, products, and solutions that the Google is providing you. And few of the services I have categorized and listed out here. So you can able to see here the compute services, identity services, networking, big data, storage, database, and machine learning services. Okay, so I have told you that this is what we are starting from today, right? So this is our course curriculum. Okay, so I'm going to talk about today cloud overview. In this one, why we need the cloud platform. We will also see what is the difference between the on-premises and cloud, and we will see what is Google Cloud Platform. Let us try to cover these things. Okay, for that one, let me go to one more slide. Okay, so hope you all can see my screen. So let us just consider. So let us try to understand why the cloud, why we are using the cloud, and what is the difference, the main difference. Or if a one new application is, if an organization wanted to roll out a new application, what would be the process in the company? So what is the flow of the work? How the flow of the work will be? So let us try to understand, because it's very important for us to understand how the requirement is created. From the requirement creation onwards, how the flow of the work to the end of the application. Okay, until the application is served to the users. So how the flow will be, let us try to understand. Let's consider if an organization wanted to roll out a new application. Okay, when an organization wanted to roll out a new application, there will be a business team. The business team comes up with the requirements for the application. Business team comes up with the requirement for the application. Then the business analyst gather the needs for the application and analyzes it and converts it into a set of high level technical requirements. Okay, business team will come up with the requirements for the application, and the business analyst gather the needs from the business and analyzes it and converts it into a set of high level technical requirements, and he will be passing that information to the solution architect. He will be passing that technical high level technical requirements to the solution architect. Now solution architect will design the architecture to be followed for the deployment of your application, and it may include the infrastructure such as hardware, software, the number of servers to be followed, the front end web server, the back end web server, the databases, load balancers, the systems, the pipeline flow. Everything will be listed out in that architecture diagram. So again, starting from one, when an application wanted to rolled out by an organization, the business comes up with a requirement for the application. Okay, the business organization or analyst team gathers the needs from the business and analyzes that and provides the high level technical requirements to the solution architect. Now the solution architect will design the architecture to be followed for the deployment of this application. It involves many things, guys. Whenever you wanted to create an architecture for the application to be created, you need to know how many servers we are using. You need to know what is our front-end web server, what is our back-end web server, what is our database, what is our load balancer, how we are managing the service, which language we are using, what is how we are going to deploy the solution, what is the deployment strategy. So all the things will be properly displayed in the architecture diagram to be followed for that. So if whatever the mentioned in the architecture diagram, if that entire thing is already available, then that is fine. In the traditional model, what will happen is that all of these, okay, whatever I have mentioned, whatever the solution architect has mentioned in the architecture diagram, all to be available in the on-premises environment itself. Because in a traditional model, we are going to deploy all of those things in the on-premises environment only. That means we are going to use the assets of the data centers of that particular company. So if that organization will be having its own data center, and on top of that organization's data center only, we are going to deploy all of this application. Okay, when you follow the traditional model, we have to deploy this in the on-premises organization environment. That means we are going to use the assets of the organization's data center. Okay, but whatever the architecture has mentioned in the architecture diagram, if all the architecture is already available, there is no problem. In the data center, if the entire environment is already there, then there is no problem. But whenever the additional hardware is required, then whenever the additional hardware is required, they would have to be ordered via procurement team. They have to be ordered via procurement team. Now, this team will put in a request to the vendors team. Okay, what they will do? They will put in a request, a new request to the vendors team, and now it will take days or weeks or even months for the hardware to be delivered or purchased or delivered to the data center. Right? So whatever the architecture, for example, assume like this. Now the solution architect is building. So in the solution architect, he mentioned the some database, backend database, some number of servers, some front-end database name, the load balancer. All of this infrastructure has to be available in the data center only. Because in the traditional working model, you are going to deploy everything in the organization's data center. This is assume that this is an organization data center only. You have to deploy everything in the organization data center only, because you do not have a cloud platform, because we are thinking about how the traditional working model is. So when you are following the traditional working model, you are going to deploy the entire infrastructure. You are going to deploy your application on top of your assets in the data center only. When you are using the infrastructure of your data center, if everything has to be available in the data center, if all things are not available, what you are trying to do is that you connect with the procurement team. Okay, we have to order it via team. The procurement team will connect with the vendors. Vendors will try to purchase the hardware and deliver that entire infrastructure to the data center. Okay, so they will purchase the hardware and then they deliver that entire architecture or infrastructure to the data center only. Okay, once I'm going to remove these things. Okay, so this is what it is. So a business team comes up with the requirement, analyst will gather the information and converts that into a technical requirements and pass on that information to the solution architect. Now the solution architect will create the architecture to be followed, and it involves the many things like architecture details and everything. And once everything is ready, 1 minute, guys. So, so whatever the architecture is, whatever the infrastructure that is mentioned in the architecture diagram, if it is already available in the data center, there's no problem. We are going to deploy it on top of that only. But if that is not available, then the solution architect will connect with the procurement team. The procurement team will create a request to the vendors, and vendors has to purchase the infrastructure and deliver it to the data center. Okay, so this is what happens. Now this delivery or this purchase may takes days or months, or even it takes some quarters also. So that's what happened, because they have to purchase it and they have to deliver it to the data center. Now assume that it takes some few days, and after that the entire hardware is delivered to the data center. Once it is received at the data centers, the field engineers will come into the picture. Okay, now entire infrastructure is received at the data centers. The field engineers will come into the picture. They are the in charge of the rack and stack equipment, and then system admins will come into the picture. They will do the initial configuration of the system, and network admins will come into the picture, and they will make all the systems be available over the network. And then storage admins will come into the picture. They create the storage and they assign the storage to the servers, and the backup admin will come into the picture. They will configure the backups. Finally, once the systems have set up as per the standards, they have been handed over to the application team. Now the application team will deploy the application on top of the hardware, on top of the infrastructure which was created by all of these people. Okay, once the infrastructure is delivered to the data center, field engineers will take care of the rack and stack, and the system admins will take care of this initial configuration of the system. Network admins will take care of the network configuration and they will make every system to be available over the network. And the storage admins will take care of the storage of the systems. And backup admins will take care of the backup of the system. And the application team will be deploying the application once the entire infrastructure is ready as per the standard. Okay, so this is what happens, guys. Okay, so this entire process has to be followed if an organization wanted to roll out a new application. Okay, this entire process has to be followed if a new if an organization wanted to create a new application. Okay, what is the problem here? So seems the problem, the everything seems good and it's a proper flow only. But what is the problem here? The problem here is that, okay, so you have a plenty of the teams working behind the scene, and some processes taking a lot of time. So the turnover time varies from the weeks to months to the everything to be ready for the application deployment, because it's taking a lot of time. You see here, if the organization's data center is not having the infrastructure, we have to go to the vendors team, we have to go to the procurement team, and that takes a lot of time. So that's the reason the turnover time varies from weeks to months for the application deployment. So that is the reason it is called as a slow deployment model. The traditional model is a slow deployment model. In a traditional model, the organization has to take care of all of these things. And while doing it, it is taking a lot of time. So that's the reason we call it as a slow deployment model. And the next thing is that the overall cost to deploy and maintain this working model is very high. You see here, there are plenty of the teams working behind the scene. There is a plenty of the architecture and infrastructure has to be taken care by the taken care by the organization, and we have to buy a lot many things, purchase it, deliver it, vendors team, procurement team. So that's the reason the overall cost to deploy and maintain this working model is very high. So that's the reason the traditional working model is expensive comparatively. And while some aspect of the infrastructure can be automated, but several steps such as rack and stack cabling, other deployment procedures cannot be automated. So that's the reason I usually call this as a limited automation. The traditional working model is not fully automated, cannot be fully automated, cannot be fully automated. That means limited automation can be done here. And with so many teams working behind the scene on so many different tasks, the chances of human error is very high, which leads to the inconsistency in the environment. And another major disadvantage is that underutilization of the resources. We also call it as a wasted resources. So you are buying more than, or you are purchasing more than you need. That's where you are going to waste the resources. Okay, so this is what is the problem with the traditional model, guys. These are the many disadvantages over the past decades. Organization moving from the cloud, sorry, from the on-premises to the cloud. It's because the traditional model is very slow deployment model, and it's very expensive and cannot be fully automated, and chances to the human error, inconsistency in the environment, wasted resources. So that is the reason, due to these many disadvantages over the past decades, organizations wanted to move, or organizations looking for a one more solution to avoid all of these problems. That's where the cloud came into the picture. Okay, so that is the reason organizations are using the cloud platforms to take advantage of the services provided by the major cloud providers such as AWS, Azure, and GCP. Okay, when you are using the cloud providers, the working model will be very fast. Compared to that, it is not a slow working model. Slow deployment model is not slow. It's because you don't need to manage all of these people because everything is already available. You just have to create your service and deploy your service on top of it. So that's the reason it is faster deployment model comparatively. And the model is also not expensive. The cloud computing model is also not expensive. It's because how much resources you need it, you can only use those resources. And again, you do not have field engineers, you do not have to take care of the system configurations, storage, backup, everything. Okay, many teams are not required. And for the data center in an organization, you have to, in a traditional model, you have to maintain this entire data center. Maintaining the data center is not easy. You have to provide 24 by 7 electricity, 24 by 7 cooling, water supply, and everything you have to provide. In the traditional model, this is what you have to do. That's the reason it makes it expensive. But in the cloud provider, you don't need to worry about the data center. You don't need to have the data center at all because the cloud provider will take care of it. So that is the reason it is not expensive. And in the cloud platforms, everything will be done via API. So that's the reason it can be fully automated. There are no many teams working behind the scenes. So that's the reason it reduces the human error. There is no inconsistency in the environment comparatively. And you will only be utilizing the resources that you wanted. You are not using the less or you are not using the more. And there's a concept of scaling also. So you don't need to worry about it. So you are not wasting the resources also comparatively. Okay, so this is what the difference between the on-premises versus cloud, guys. In the on-premises, you are facing these many problems. But when you go to the cloud, these problems are not there. Any questions here, anyone? Please raise your hand. If you guys are unable to understand this point or anything, does anyone have any questions on this one, guys? So this is how the application flow. Whenever an organization is getting a requirement for the application deployment, this is the flow. This is the flow in the organization. If it is following the traditional model, and if you are following the cloud computing model, you don't need to take care of this one. You don't need to take care of this one, this one, this one, this one, this one. You can directly go for the application deployment. Only there is a DevOps team will be there. They will create the infrastructure to you, and you can deploy your application on top of it. Okay, so in simple words, if I have to talk about what is the difference between the traditional working model and cloud, in a traditional working model or in an on-premises environment, an organization managing its own infrastructure to run their codes or applications is nothing but a traditional working model. In a traditional, organization has to manage its own infrastructure. The entire infrastructure has to be managed by the organization only. And so that is what is nothing but a traditional working model. In the cloud computing model, the cloud provider delivers the infrastructure as a service to you. So you don't need to manage your own infrastructure. Cloud provider will manage the infrastructure for you. You can focus on the development. So if you ask me about what is infrastructure, the infrastructure can be a servers, can be a hardware, can be a software, or a networking, or a storage. Okay, so in a single statement, If you manage your entire infrastructure at home, is nothing but on premises. If you are not managing and one more cloud provider is managing your infrastructure, is nothing but a cloud computing model. Okay, so this is the difference, guys. Anyone have any questions? So we will see this one later. And I have also told you maybe yesterday only what is Google Cloud Platform. So Google Cloud Platform is a suite of cloud computing services provided by the Google that offers the products and solutions to help organizations to build, deploy, and the scale the applications and services in the cloud. Google is providing you these many suite of services you can able to see here. It is providing you the compute services, security identity services, management tools, networking, big data, storage and databases, machine learning services, many more. If you wanted to see all the services in the Google Cloud Platform, you can go to the Google. I'm going to show you how to create an account, guys. Don't worry. So you can go to the products and solutions. This is what we call as a navigation menu. You can click on it. And here you have a second page. You can click on this products and solutions. You have all the products here. More than 4,000 products and solutions available in the Google Cloud Platform. You can able to see all the products, platforms here. Products and solutions here. Okay, so these many products and solutions are provided by the Google. Okay, and why we are going to learn the GCP? It's because Google has a very good community support. We have been using the Google products from the last decade. The services are cost effective compared to the other cloud platforms. The services are flexible and scalable up and down. You can able to scale your resources according to your requirement. Whether if you wanted to increase your resources, you can easily scale up, or if you wanted to decrease your resources, you can scale down it. And the services are trustworthy, and it is provided. I mean, it provides you the proper security. You don't need to worry about the security of your services and data and everything. And it also provides you the services such as the fully managed services, and virtual machine based services. The interface for the Google Cloud Platform is very simple and it is very fast. Okay, and it is the market leader. It is one of the top three leading cloud provider, guys. And from the small organization, MNC companies, product based companies started using it, and there is a industry adaptation. So that's the reason you have a plenty of opportunities right now. It has a comprehensive service portfolio. I have told you, right? It has a compute services, storage services, database services. So it is having a comprehensive service portfolio, and integrate it can be integrated with all other systems in the on premises, all other cloud platforms also easily. It provides you the machine learning capabilities as well. It has a global infrastructure throughout the world. Multi-cloud projects. So, I mean, the next era is that you are going to work in the multi-cloud, guys. So earlier we worked on the on-prem, right? We worked on the on-prem. Now the era is that we are working in the cloud platforms, one single cloud. But maybe few days after you are going to work in the multi-cloud projects. That means in one project you are going to use most of the cloud platforms. So here one cloud we are using. Here you can use two or three or more than two cloud platforms also you can use. In that you must learn the GCP, and GCP has a very good certification and career growth opportunities. Whoever is certified, right, the opportunities are more for them. and the chances of getting hike and the chances of getting selected is more for those who are getting certified already. Okay, so this is why we need to learn the GCP, guys. And growth rate for the GCP also you can look at here. The growth rate compared to the AWS, compared to the Azure, the growth rate for the GCP is more. You can see here in the last quarter, the growth rate for the GCP is more than AWS and Azure also. That means what is meant by growth rate in that particular period? So the number of companies you started using the AWS, the number of companies started using the Azure, the number of companies started using the GCP is more compared to the all other clouds. GCP is more the growth rate. That means you have a plenty of opportunities now. You can see, and with this particular course, you can actually go for the GCP data engineer, GCP developer, and GCP admin. Okay, so for those people who wanted to go for the GCP data engineer, this is your perfect course. For those people wanted to go for the GCP developer, not all the concepts are covered, but 70% of the concepts are covered here. For GCP admin also 50% of the concepts covered here. Okay, 100% of the concepts for the data engineer is covered here. So this course is more of a GCP data engineer, guys. Okay. And if you wanted to do any of the certification, GCP provides you two certifications, guys. If you are going as a GCP data engineer, one is associate level certification. Sir, I wanted to do the associate cloud engineer. I am a DevOps engineer. I am a developer. I wanted to do the associate cloud engineer certification. All the topics are covered here. If you wanted to do the professional data engineer certification also, you can able to attend. You can able to easily crack it. I have created the dumps for you as well. I will share it to you guys. Okay, anyone have any questions so far? Please raise your hand if anyone have any of the questions. Yes, yes. Yeah, hi. Cost cost effectiveness is the main important thing. Okay, but by providing you the same quality, by delivering you the same service, same configuration, same quality, and same security, but it is cost effective. Okay, so that's the main thing. And cost effective, you can say the big data services are far better, far more cost effective compared to the AWS and Azure. Okay, but the cost effectiveness is more for the GCP data engineer. Hey, sorry guys, can you hear me?
Yeah, yeah.
Yeah, I'm really sorry. I got lost in between. So yeah, sorry. Yes, yes, you were asking something, right? So this is related. That's what I'm talking about. It provides you the cost-effective services compared to the AWS and Azure. Okay, that's why see the cost is the more impacting factor, right? So when you are dealing with the plenty of the clients and your clients wanted to have a cost-effective solutions, and you can't build the cost-effective solutions where AWS and Azure because they provide you the costly services. but the GCP is compared to them, it is cost effective. One more thing is that, so if you wanted to do the data engineering activities on top of the other AWS or Azure, but the same service in the GCP, the performance of the application is very good because Google Cloud Platform is having a very good library for the data engineering activities. You may name Dataproc or a Dataflow or a PubSub, or all these are very famous tools. And BigQuery, commonly you BigQuery is one of the highly rated from the Gartner, one of the data modern data warehouse tool, highly rated, even compared to the Redshift and Synapse also. So that's the reason it's a very famous, yeah, comparatively. Okay, any other questions, anyone, please?
Okay. Shaik, today is my
Yes,
first
please.
day. I'm not sure what are the topics already we have covered, but I am keen to go through your curriculum. Sorry for interrupt. If you're done
That's
with your
fine. That's
session
fine. I
for today,
think
right?
in yesterday's session also I've shared. I'm going to share it here, the curriculum with you guys.
Yeah, I
Okay.
have seen it. I have seen even online curriculum, but I'm keen to know on what level you're covering this thing. Okay, we will start from top to bottom now, rather, because already I'm working in one of the big, GCP project for last 2 years. I currently work for
Okay.
Cloud Data Fusion and BigQuery, but I'm keen to learn Dataproc and Dataflow. I've seen many Udemy
Yeah.
courses, but I'm not getting enough time, so this is I joined here so that I got some time. Okay,
Yeah.
the
Yeah.
very
Sure.
first thing, could you please walk me through your curriculum, what you will be covering over this period, and then it
See,
will be for
my
45
curriculum will be like
days.
this. So I'm going to explain theoretically all the concepts. I'm going to explain, have a lab sessions for each and everything. For example, you named it Dataproc and Dataflow. For the Dataproc and Dataflow, we will be covering what is Hadoop, what is the difference between Hadoop and Spark, Spark and PySpark, Spark introduction, cluster creation. Okay, how do you create the cluster? What are the challenges while creating the cluster? How do you create a single node, multi-node cluster? And after that, we will be having a lab sessions. So the lab sessions is all about how you create your data frame, because we are letting the PySpark with data frames, and how do you do all of these actions,
Okay,
filtering the data, transforming all the transformations we wanted to. And while we are learning, how do you read the data from your source? How do you write your data to? So, for example, your data, you wanted to read the data from JSON, CSV, Avro, Parquet, Excel, BigQuery. How do you read it and create a data frame? And if you wanted to do any of the transformations like this, all these transformations we are going to learn. And after that, how do you write it to the sync? So all the lab sessions are here only, extracting, transforming, loading, and you have a job one and job two, and we have an end-to-end pipeline also. So you have here the code, the explanation of the code also here. Here we are using all the libraries, errors, storages, path session, setting up the variables, reading the data from the BigQuery, filtering the data, writing it to the GCS, and renaming and copying the files in the GCS, because we don't want it to have unnecessary temporary files to get created. So everything is properly created, and you have the case studies, case study 1, case study 2, case study 3, assignment 1, assignment 2. Similarly for the data frame also. Oh, no, sorry, data flow also.
Dataflow.
Introduction. So most of the people does not know the Apache Beam. So we will be starting with Apache Beam. What is Apache Beam? How to work with Apache Beam in Apache Beam? What is the driver and everything? And afterward, the Spark versus Beam. What is the difference between the Apache Spark and Apache Beam? Data
So
proc and data flow.
even we will get to see this difference in lab sessions also, right? Spark versus
Yeah.
Bean.
Sorry, which one?
Spark versus Bean, Apache Bean and Spark.
Yeah, in this course, we are
Even
going to learn Apache Beam first. See, data flow is an engine, okay? Data flow is a runner, okay? It runs your code, but you need to write your code with Apache Beam only. You are going to
yep,
have, see, for example, let me open this one of the page. You are going to learn each and everything here. How do you read the data from CSV file, JSON file, BigQuery file, all of these things. So this is source and this is transformation. So you look at here the transformation. So if you wanted to extract the same thing, so this is how you write your code. So the code becomes keep on complex. Okay.
okay,
So when you are writing your C, so when we started learning the transformations, it was only one transformation. Then after that, two to three transformations. After that, 4 to 5. You see here, these lines are nothing but transformations. And you see here, You started using the classes, you started using the functions, and you are making your pipeline even more complex. Okay, so this is how it is. And after that, we have an end-to-end streaming pipeline. We have a end-to-end batch pipeline and streaming pipeline using the pub sub. What is pub sub and everything also I will discuss here. So it will be power pack. I mean, fully packed. What I would say, the
Okay.
course where you will be we will be covering everything. Okay.
Okay.
So data
So
prop,
in
data flow,
this,
airflow also. Yeah.
okay, even in the pub sub, right, we will be having active subscribers and publishers both, right, from BigQuery or whatever.
So I
Both the
will be
things will be
creating
covering.
the publisher application, a random Python application. I will create it. I wanted to send the data to the BigQuery.
Okay.
Okay. Okay, something like that using the pub sub.
Okay.
We will be doing
Okay.
that. Yeah.
Okay. For all these tools, what is the prerequisite? Is it Python or Java?
It's SQL is more than fine. SQL
SQL is more
is
than fine.
the basic requirement for this course. SQL is the
Okay.
basic requirement for this course, guys. For all of the people, the familiarity with the SQL is very much important for this particular course.
Okay.
Yeah.
Got you. And then you even have data fusion. Could you please click on data fusion? So even in data fusion, you'll be creating all these pipelines, right?
No, for the
Similar
data
pipeline.
fusion, it is limited because some people not using the data fusion, some people. But in a data fusion, I will be covering, I mean, one pipeline, maybe only one pipeline. We are deploying one pipeline only. Okay.
Okay.
Yeah.
Okay. And
Because
what
it's
should
we don't need to write the code, right? It's most of the things are self-explanatory. We are not creating any code here in the data fusion. So I'm going to explain the flow and I'm going to give one assignment also here. Yeah.
Okay, okay, because here, right, I little struggle to write custom plugins in Data Fusion.
So those that we are not covering. Yeah, that we are not covering.
Okay,
Custom plugins we
okay,
are creation we are not covering. Yeah.
okay. Data prop, data flow, airflow, and data vision is the only thing which you're touching minimum. Otherwise, everything else you're
Yes,
covering
all
from
other things are good.
scratch.
Yes, because I mean, data fusion, most of the companies are not using actually, but some companies are using. So that's the reason we are not touching. Even nowadays in the interviews, also they are not asking. They are more focused on BigQuery, data flow, data proc, airflow. These are the four
Yeah.
main things they are focusing. So all these four things are properly created, and we are discussing everything here. Yeah.
Okay. What about these functions? Is it in cloud functions?
This is cloud functions only. Yes, we are having a cloud functions on. Also, we have a real time and we have a lab sessions also. One is cloud storage, one is PubSub. Yeah.
Okay.
Okay. Any other questions, please? Anyone have? Okay. So let us. No. I mean, just what is Kubernetes engine? That's what we will be covering. Okay. Not more than that. Okay, you can look at my curriculum also, just because that's not related to the data engineering, but you should know some knowledge on it. So that's the reason. What is Compute Engine? What is Kubernetes? What is App Engine? What is Cloud Run, Cloud Functions? Only what is what here, not more than that. Okay, only definition point of view. Okay, you should know the difference between virtual machine, containers, App Engine, Cloud Run, and Cloud Functions. That's it. What is what we are covering, not more than that here. Okay.
So even a labs will not be covered, even single session, how to create compute
Yes,
engine or
Ajay. Yes, Ajay. Yes, Ajay.
sorry, is there audible? Right.
Just wait a minute. Wait a minute. Okay, please raise your hand if you wanted to talk. Okay. So there are multiple people are asking at the same time. So yes, Ajay, you are asking something. Sorry. Okay. 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 Correct. Okay. No, we are not covering that. So this is more of a data engineering course. Yeah. Yes. So that's a DevOps. I mean, that is covered in the DevOps sessions. Okay, application, not application migrant, but whatever the things you wanted to work in the cloud architecture, when you wanted to select or deploy an application, that's more of a GCP DevOps concepts. What you are asking is, yeah, yes, yes, someone was asking.
This is Anwar. Hope I'm audible.
Wait.
Okay.
Yeah, Anwar, yes, Anwar, yeah.
I have seen even this Kubernetes and virtual machines. Is you are covering them in lab sessions or only theoretical
No, only
concepts?
theoretical, guys. So this compute options is to give you, this is, you can think of a bonus topic for you to make you understand or to know that there is a virtual machines, compute engines, Kubernetes app engines. These are the compute options provided by the Google Cloud Platform, and this is what this is. Only definition point of view, not more than that. Hardly I
Okay.
take 1 hour session to cover all of these things. You can understand that, okay?
Okay, got it. Could you just scroll up just to
Okay.
show the curriculum? Okay. This IAM policies, right? The fourth module, IAM
Yes.
policies. So this will be limited with just on front end control, or even from back end side, you will be showing through how to control IAM.
No, in the IAM, it's more of a project management. So if you wanted to
Exactly.
manage your entire project, access roles, create policies, hierarchies, if you wanted to manage everything, so you'll be learning all of those things here in the IAM. Yeah.
No, but you will be teaching us from the GUI web console or from backend, like
No. We are learning it from the web console only.
web console. Okay.
Yeah, we
What
can able
about
to. I
this?
mean, while we are deploying some applications, while we are working with some other systems or services, we will be creating the service accounts from the external. But most of the things we will be doing in the console only, and you can do
Okay.
some few of the things from the cloud shell as well.
Okay. What about this GCP networking, VPCs,
So
right?
that's actually not covered here. GCP networking is not for you guys. This is more of a DevOps topic. Actually, I should actually remove it. But why I have mentioned here is that, so while in one of the cloud SQL, we need to create a Linux virtual machine on in GCP we need to install the MySQL on top of it. So if I wanted to do the data migration, so we are covering one of the data migration from on-premises MySQL to the cloud MySQL. So I need to set up all of these things. If I wanted to set up all of these things, I need to give you what is firewall. Okay, you should understand what is firewall, at least some basic understanding. So, and you need to understand the VPC. So for that one, I have mentioned here, this is not your topic, but maybe the definition point of view, it will be covered here. Okay, what is
Okay.
firewall, what is load balancer, what is virtual private.
Okay.
Okay,
Okay. Got you. Could you please scroll it down to the next module, 7?
so here it is.
Okay. Cloud storage, introduction to cloud storage operation, data transfers, versionizing, integration. Okay. This cloud sequence. Okay.
So you
This
can
big
actually go through
tables.
the curriculum. Let's not waste others' time.
I'm
Okay,
understand.
okay.
No,
You have the
you
curriculum
will
link and
be
once.
covering. No, why I'm raising is that why I'm going to this curriculum is that you will be covering lab sessions for this ones, right? From
So
here,
that's what
cloud
I
store.
told you, right? I have told you we will be having a lab sessions for each and everything. Okay, whatever I have
Okay.
mentioned here, we will be having the lab sessions for each and everything. Okay, so I think I might have told you in our lab sessions also. Here, this is what is our lab sessions looks like. So here we will be having GCS,
No,
Bigtable,
introduction.
Cloud SQL, and BigQuery. For all of four, you will be having lab, but we are not covering the Bigtable. Okay, Bigtable is not there, but GCS, Cloud SQL, BigQuery, and after that, data proc, data flow, data fusion, airflow, and we have a Terraform. So all these four sessions also you have lab sessions, and you have additionally PubSub. PubSub also you have lab sessions.
No.
Okay.
Okay. Sorry, Sheikh. Today's
Yeah,
my
yeah,
first
no.
session. That's the reason I'm asking for the labs. I'm keen for the labs. How you will be
Yeah, this
covering
is
this?
everything. I can assure you that whatever I am mentioning, it is lab means it is lab. You can also go through my notes, okay? So if you go through my notes, maybe I'll be sharing it to you on Monday. When you go through my notes, wherever you see, maybe for here, you see these are all lab sessions only. Okay, interacting with the Google Cloud Storage by yourself. I can't just say, okay, you can use GSUtil, right? I have to write this command. I have to list out all of these commands, and I have given assignment also here. And one more thing, if I go to the Cloud SQL, we are doing the data migration. So how do you data migration in the console, and how do you manually do the data migration? There are two types of data migration we are covering: manually, how do you do that, and automated way, how do you do that? And for doing that, we need to have installed a virtual machine on top of the MySQL. We have already that. And for the BigQuery also, we have BQ assignment, case study 1, case study 2. In the case study 1 also, we have everything, labs. And data proc also, we have labs. Data flow also, we have labs. Airflow also, we have labs. Okay. So whatever, if I say labs, that means labs are there. Yes. Almost 6 to 7 services full-fledged we have to learn, because that is all our data engineering only. For example, GCS, Cloud SQL, BigQuery, Dataproc, Dataflow, Airflow, Data Fusion. These are almost 7 services. We must learn these services. 8 services, yeah. We must learn these services. Okay. Yeah. Anyone have any other question, please? One was asking in between, guys. Sorry. Okay. If anyone have any questions, you can ask me. Okay, so we will cover the few more topics tomorrow, guys. It's already 8:30. I just wanted to. We will be having our sessions from 7:30 to 8:30 only every day in the morning. And tomorrow also we have our demo session. Please attend the demo session tomorrow as well. That is our third demo session, which is free for you all. From Monday 7:30 to 8:30 onwards, it's regular sessions. If anyone wanted to go for the regular sessions, you can actually enroll for the course. Okay. So this is it, guys. If anyone have any questions, you can ask me. Otherwise, we can wind up the session for today. Okay. Okay, guys. Thank you all. Have a great day. Bye-bye. We will meet on tomorrow's class. Thank you.